Let's talk about how to calculate the area of a polygon that's been placed in the coordinate plane. Oftentimes you'll need the distance formula in order to achieve that goal. Remember that you can count the distance of a horizontal or a vertical segment, but if your segment is diagonal like this one shown here, you would have to plug your points into the distance formula to calculate the length. So on something like this, it's pretty straightforward. You get to just count because all of the sides of this rectangle are either horizontal or vertical. The top and bottom sides are each 7, and the left and the right are each 4. So to calculate the area, you just multiply base times height, which is 4 times 7 or 7 times 4, the order there doesn't matter. Either way, you'll get to an answer of 28 square units. And the perimeter is the sum of all 4 sides, so 4 plus 4 plus 7 plus 7 gives you a total of 22 units. But not all problems will be quite so straightforward, like this one. I cannot count the lengths of each of the sides of this square, because they're not horizontal or vertical. So in order to calculate the area and the perimeter, the first thing I need to use is the distance formula to calculate the length of one of the sides. Since it's a square, as soon as I know one of the sides, I'll actually know all 4 of the sides. So identify 2 of the coordinates, like E and H, and plug those numbers into the distance formula. x2 minus x1 squared plus y2 minus y1 squared, and we get that EH is approximately 5.4 units long. Now I can use that information to calculate the area. The area of a square is equal to the side length squared, which should give you an answer of 29 square units. However, you might have gotten an answer of about 29.16 square units if you had used the rounded version of 5.4. But remember where this 5.4 came from. It came from the distance formula. It was not just 5.4, that was the rounded decimal of 5.385164807 yada yada yada. So if you use that entire decimal in your calculator and square that, instead of squaring just 5.4, you get the exact answer of 29 square units. Then if you add all of your 5.4s together, there's a total of 4 sides, each of them is 5.4, but remember it's actually 5.385164087, so when I add all of that up, I actually get a total of 21.5 units, not 21.6 units. So be really careful with how you're rounding things. In other words, don't round. Keep all of the decimal points in your calculator, and it will get you to a more exact answer. Let's try another one. This time we're going to calculate the area and the perimeter of this parallelogram. The area is pretty easy because the base is horizontal and the height has to be perpendicular to that base, so the base is a vertical line that gets drawn between the 2 bases. So each of the bases is worth 5, and the height is a total of 7. So the area is just 5 times 7, so 35 square units. But to calculate the perimeter, we need to know the length of Li and the length of JK, and we'll need the distance formula in order to do that. You only have to use the distance formula once though, because since this is a parallelogram, the opposite sides are congruent, so as soon as you know one of the slanted sides, you'll know the length of the other one as well. So let's just identify these 2 points and plug them into the distance formula. And when you simplify, you get an answer of 7.3 units. Now I can calculate my perimeter by adding 5 and 5, which were the lengths of the bases, and 7.3 and 7.3, and get to a total of about 24.6 units. Next, let's find the area and perimeter of this triangle. Again, we're pretty lucky because one of the 3 sides is horizontal or vertical, so we can just count its length. The length of MN is 7 units long. And since we have a side that is horizontal, we can easily draw the height as being perpendicular to that. That would be a vertical length between the base that connects to the opposite vertex. And the length of that segment is also 7. So the area of this triangle is 1/2 times 7 times 7, which is 24.5 square units. However, in order to calculate the perimeter, we're going to have to use the distance formula twice. The distance between M and O can be calculated using the distance formula, and the distance between N and O can also be calculated using the distance formula. Alternatively, if you feel more comfortable using the Pythagorean theorem, that is another option. Basically, we divided this triangle into 2 right triangles, one of which has a side of 7 and a side of 5, and the other has a side of 7 and a side of 2. So you could say 7 squared plus 5 squared equals MO squared, and 7 squared plus 2 squared equals ON squared. And those will get you the exact same answer as the distance formula. Either way you cut it, you're going to find out that the perimeter is about 22.9 units. Next up we have a rhombus. In order to calculate the area of a rhombus, you need to know the lengths of the diagonals. And thankfully the diagonals here are horizontal and vertical, so you can just count their lengths. The vertical diagonal is split into 2 and 2, so a total of 4, and the horizontal diagonal is split into 4 and 4, so a total of 8. So the area of this rhombus is equal to 1/2 times 8 times 4, which is a total of 16 square units. However, in order to calculate the side lengths, we would again need to use the distance formula. Or like I said on the previous problem, if you feel more comfortable, you can also use the Pythagorean theorem. On this problem, I'm going to show you what it looks like if you use the Pythagorean theorem. Basically, when we drew these diagonals, we divided the rhombus into 4 congruent right triangles. So I could use the Pythagorean theorem on any of these to calculate the length of the side. Once I know one of the sides, I would know all 4 of the sides because it's a rhombus, and the sides of a rhombus are always congruent. So here we go. 2 squared plus 4 squared equals PQ squared. That's leg squared plus leg squared equals hypotenuse squared. Simplify, and you get an answer of about 4.5. Which means all 4 sides have a length of 4.5. So I'll just multiply 4 times 4.5, but keep in mind that 4.5 is actually a rounded version of the square root of 20. What you're actually saying when you're saying 4.5 is 4.472135955 yada yada yada. So when you multiply this 4 times 4.5, you're not supposed to get a pretty little answer because this is rounded and you shouldn't round until the end of your problem. So when I multiply 4 times 4.5, it would have given me 18, but if I multiply 4 times 4.4721 blah 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 blah, it gives me 17.9 units, which is a more exact answer than 18. So again, be really careful with how you're rounding. You should not round in your work. Keep all of the digits in your calculator as you're working through the problem. The only thing you should be rounding is your final answer. What do you think about our final problem? Do we have a formula for a squished hexagon? No. So what are we supposed to do? Well, what if we broke up this shape into more manageable pieces? For example, we could divide this up into 3 different shapes. 2 of them would be triangles, and 1 of them would be a parallelogram. We have formulas for triangles and parallelograms, so that would be a way for us to find our answer, by breaking it into its pieces. So if I look at this little triangle, EFJ, it has a base of 4 and a height of 2. And I see a congruent triangle on the right side of my diagram. Triangle GHI also has a base of 4 and a height of 2. So the area of each of those triangles would be 1/2 times 2 times 4, which is 4. What's left over in between those 2 triangles is a parallelogram. Remember that the base does not have to be the side that it sits on. It would be pretty challenging to use side JI as our base because we would have to find a length that's perpendicular from JI up to FG, and that would be way too much work considering we have one of the sides of this parallelogram is vertical. So if I use 4 as my base, I can draw a perpendicular line from that side to the other base, and that can be used as my height because these 2 lengths of 4 are perpendicular to each other. So the area of the parallelogram is equal to 4 times 4, which is 16. So the area of the shaded region, which is both of the triangles and the parallelogram, is a total of 24 square units. And that's all you need to know about calculating the area and perimeter of polygons that have been graphed in the coordinate plane. In our next video, we'll be moving on to calculating the area and perimeter of composite figures.